Hello, my name is Carl Cook. I'm President and Chief Technical Officer of Biocomp Systems, and I'd like to give you a brief introductory video of how to create your first bot, which will be a random signal generator, and to do so in 15 minutes or less. And random signal generator is not particularly useful, but we'll take you through the process of building something and getting it into Dakota and show that it works. So, all right, let's get started. The first thing you need is Visual Studio Express 2012 for Windows Desktop. There's a bunch of different ones, but the Windows Desktop one is the one that you need. And I will put a link on how to get there, download it from Microsoft in the description below the video. And I would like to thank Microsoft for providing the most powerful development environment for Dakota known to man. And so let's get started. So the first thing you need to do is to create a new project, and we're going to create a class library. And you have some choices in languages. You can choose Visual Basic or Visual C#. Visual Basic is a little more loosey-goosey language, and it's easier to use, probably, particularly for the newer developer. The more disciplined developer might choose to use C#. Those are the two languages that we recommend, and we develop in both ourselves. And so what we want to do is create a class library project called randsig, just so we know what it does. And we will click OK. And it goes off and creates a default project. Now, there's some housekeeping that we need to do, some technical adjustments to the default project to use it within Dakota for a couple of reasons. One is the Intellect library is .NET 3.5 and it is 32-bit. And so we need to match up with that. So let's go ahead and you double click My Project and it'll bring up this dialog, which is kind of a configuration thing. And right away it shows you the target framework. We're going to change that to .NET 3.5. And then under references, there's a couple of things we're going to do here. We're going to reference the Intellect DLL, and there's also, if we scroll down, something that does not take out when you switch from 4.5 to 3.5, which is this threading thing, which we don't need. So we uncheck that box. And we're going to add in the Intellect library. Now I've already accessed the library previously, so it's already in my recent libraries list, but I'm going to go browse for it because you'll need to the first time. And you'll probably find that library under C, Program Files x86, Biocomp Systems Dakota 3. And right here is intellect.dll. Click Add. Click OK. Now it's added in. I'm going to click Save and close out this. That's what we need to do on that part of it. Now, there's one other thing. The Intellect library is 32-bit, and our library needs to be 32-bit. So drop down any CPU and go to Configuration Manager, because any CPU means 64 or 32, and really that means 64. And we're going to change the active solution platform. We'll drop this down, click New, drop this down and select x86 and click OK. And I'm also going to set this as release. You can debug release DLLs, and we'll show that in another video. And debugging a release DLL seems kind of paradoxical to me, but it's possible. And okay. So now we've done our homework, and now we need to start working on our project. So I'm going to change this to randsig for the name. It doesn't matter what you name it. And then I'm going to inherit a bot object, because what we're building here is a bot. A bot is a trading system. A trading, in the parlance of Dakota, that is a trading system that has parameters that are walk-forward adapted by the swarm algorithm. So we need a trading system that creates a signal, and we also need parameters to be able to adapt. So I'm going to inherit a bot, which is going to give me a bunch of functionality. So inherits intellect dot adaptation dot bots dot bot. Now we have a whole bunch of functionality in here you don't see. We're going to give our bot a name and a description. So we're going to create a function that's available in all objects. Public sub new. And this function is called whenever this object is created. And so we're going to give it a name, and you'll see that name exists. Name equals my rand sig. And I'll give it a description. You'll see description exists. This guy spits out random numbers. All right, so we need a way to create random numbers. So we go up here. This is at a global level in the object, and we declare a private, it can't be seen outside this object, rand as random, which is a random number generator available within .NET, equals new random, which means it will get created when this object is created. And now we're going to create, we're going to override a function called createSignal, which is already within the intellect.adaptation.bots.bot function, and we're going to override that to provide our function for how the signal is created. So how do we do that? Public overrides. Then they get a whole list of different things, and one of which is createSignal. So I click on that, and it will throw in this call to the base bot objects, createSignal. We don't need that, so we take it out. Now what this function does is that it gets called by Dakota, and it passes in a 2D array of doubles. In the previous video that was string. For performance reasons, we turned that back into doubles like it was in the older Dakotas. And 2D array means that the columns are the different data series that are coming in from either the data source or indicators that you build within the indicators tab of Dakota. And the rows are time, with the most recent at the bottom. And what it asks us to do is to return a double precision floating point number to be used as the signal from this bot. So we return rand dot next double, and then that's between 0 and 1. So we subtract off a 0.5, which will give us a number plus or minus a half. So it bounces back and forth across 0, long, short. Negative number is the short indication. The positive number is a go long, go or stay long indication. So now we have done that. Now this is a walk forward adapted parameter trading system, but this random signal generator doesn't need any parameters. But we're going to create some anyway so we can see them in Dakota, and it's kind of a requirement that there at least be one. So up here we have a create parameter. So when the object is created new, there's a function that's available called to you for Dakota called create parameter. And you can have all sorts of different kinds of parameters, but floating point, double precision numbers, integers, and true false are supported. So parameter value is double. We give it a name, my parm number 1. We can give it a description, which I'm going to leave blank. And then we also have a minimum, maximum, and a starting value. So the minimum might be 0, the maximum might be 100, and the starting value might be 3. And then the last item on here is true false. Is it optimizable? And what that means, if it's true, then yes, the Dakota will adapt this thing through multi-dimensional parameter space. If this is false, then it's something that's purpose is not to be adapted, but is just something in the user interface that you can use to switch things or set certain other things that not to be adapted. So there's adaptable and non-adaptable. So we're going to call this true to be adaptable. And just for fun, so it looks cooler in the user interface, I'm going to create 3 of these. And I'm going to call the second one bananas, just for fun. And I'm going to call the first one puppy. Whatever. You can call them whatever you like, and they can be different. So let's make this a -10 that goes to a +10. Maybe it starts off at 0, etc. So it can be, you can make them anything that you want. Now, I do believe we're done. So we'll go over here to RANSIG, right-click, and build. And we look down here, build, 1 succeeded, 0 failed. There's no warnings or anything. We're cool. And here they've nicely given us the path to the library. So we're going to go ahead and just grab a chunk of that path so we can navigate more easily. So now we go over to Dakota. And here we have Dakota. It's just started up. It's got a default swarm window all set up. And we go to swarms and drop this guy down. And here's what we're building, the signal generator. By default, it's set to a moving average crossover. We're going to add in what we just did. So what do? You click the import library and you paste the path that we snagged. And we're in the RANSIG bin x86 release folder. And what do we want? We want that RANSIG DLL. There's a lot of other stuff in here that's pulled over from things that the Intellect library references. You can ignore that junk. We're just after this RANSIG and click open. Now we see it. We have it in our tree. We can move it over here. We can drag and drop it around. We can do what we like. And we set it to this, and here's our parameter values. My parameter number 1, bananas and puppy, and they're as we set them before. So now we're ready to go. Oh, no, not quite. We need to get some data. So I just double click on Cocoa. Mind these dates here. I have mine set to 1/5/2010 to 9/12/2013. And now I have data. Here's the indicators tab. This is what's going to get passed in that 2D array of doubles. And here's the swarm tab. And what we're going to do is, we don't have to go through all these at this time, but we've got this my RANSIG set ready to go. And we're going to push go. And we'll see that this is progressing. And if we go over to the parameter scatters, we see that my param1, bananas, and puppy are all moving around. The colors changing based on whether or not they're profitable at that moment. And we see an equity curve chart going here. Now, this chart is a little slow, and so we're going to replace it eventually, but you can make it go faster by sliding that over. How much faster? Well, let's run that again. That took 24 seconds. Let me run it again. Bink. 2.23 seconds. So anyway, that is how to create a bot from scratch and put it into Dakota and run it in 15 minutes or less. So we showed the Visual Studio 2013 desktop version that you need, and we chose Visual Basic as the language. We created a class library project. We did some housekeeping on changing the .NET version to 3.5 and removed the threading thing, and we referenced Intellect. We made it x86 release version. We inherited a bot object. We created the name and description, and we created a random number generator out of .NET, which we use in the create signal function, which returns a random number. We built it. We went into Dakota. We added it in. We moved it around the tree, and we pushed the go button, and we ran it. And there you have it, all within 15 minutes or less. Thank you very much, and stay tuned for additional videos upcoming.